But yeah, if people are kind of putting together the whole process of these particles coming off from comets and asteroids, and just when you hear based on their questions that they really understand what's happening, that's fun. I guess, yeah, you would consider that a high level question.
Yeah.
Yeah.
Okay, excellent. Well, that's wonderful. I appreciate you joining us. I'm going to let you go back and spend at least another 30 minutes answering questions. If you have questions you want to tweet to and have Rhiannon actually answer your question live on social media, all you got to do is send your question, tweet it to @NASA_Marshall. Use the hashtag #AskNASA. And then her and Danielle and Dr. Cook will take the time to answer your questions live tonight. Thank you a lot. I appreciate it.
Yeah, it's been fun. Thanks,
awesome.
Chris.
That's been Rhiannon Blau from NASA's Meteoroid Environment Office here at NASA's Marshall Space Flight Center, talking Perseids all night long. And so very excited. We've had great guests. One of our first guests earlier this evening, we had a great response and great time talking to him. If you missed him earlier during the live interview, we actually were fortunate enough, thanks to the television studio crew at the NASA Goddard Space Flight Center, they were...
The whole of a meteorite and study the composition of these rocks, we can have a better idea of what these bodies that are either the primordial block of a creation or the remnant of the creation, such as the asteroids. We can then see what type of elements they existed before planets were created and the solar system became what it is now. So it's always very useful to understand what are the main elements that exist on these bodies or particles.
Thank you, Dr. Diego Hunches. We appreciate that. Appreciate your time, not only joining us tonight live earlier via telephone for a wonderful interview, but also for taking the time out of his busy day to go into the NASA Goddard Space Flight Center television studio and creating some videos that we can air not only tonight, but for future broadcasts. Here at NASA Marshall, we conduct lots of webcasts and broadcasts just like this one. This one is for Persaid Meteor Shower. We do them for lunar eclipses and solar eclipses, and so it's a great opportunity to have him involved and sharing his knowledge with us. Wonderful opportunity. And so moving along, we've got a lot of great content. And one thing we enjoy is having hands-on displays. And so earlier we talked about the International Space Station and all the tie-ins with that. Here on Earth, we're protected by Earth's atmosphere, and so the meteoroids in space will come through the atmosphere and they will start to ablate and burn up and create that meteor streak, and that streak is the meteor, and then they might hit the ground and become a meteorite, which is very rare. Most of them burn up, but the atmosphere protects us, and so that's a great opportunity or a great benefit from living here on Earth. But if you're a space explorer, as our astronauts are who are on the International Space Station right now, they don't have an atmosphere to protect them, not like we do here on Earth. And so they need to be protected in the International Space Station, and they do that with shielding. We heard Dr. Bill Cook earlier tonight explain that the International Space Station is basically an armored space laboratory, and some of the armor is right here with us right now on the desk, or something similar to that. I want to say the same armor, but same kind of similar protection that you would find on some of our satellites and spacecraft. And so see on the front here a large piece of metal, and we have hypervelocity guns here at NASA Marshall, which we can shoot different materials and test the structure of different kinds of protective material and coating. And this one is a metal shield. You can see right here we have a hole in the front where our material has gone through. The projectile has impacted the metal and it's completely gone through. And on the side, from the side view, you can see what looks like a cloth padding, but it's not cloth, it's a Kevlar material, it's a bulletproof material. And so from the side view angle, you can see where a projectile fired by one of our hypervelocity machinery here to test the strength of this material would go through the first panel, would hit the Kevlar material in the center. But if you look on the back end there is no hole on the back end because the Kevlar material actually slowed down something that would be similar to a meteoroid that would impact the International Space Station or one of our satellites or spacecraft orbiting the Earth or traveling throughout the solar system. And so this is a representation of the kind of material that we use on spacecraft and satellite to protect not only the astronauts but all the hardware and software that's involved in that. And so it's definitely something that's very important. We want to make sure we protect everything that we put out there. And so that kind of material right there, it's great to see some of the research that's gone into protecting our spacecraft and satellite as we talk all things Perseid all night tonight on our live broadcast of 2015 Perseid Meteor Shower here from NASA's Marshall Space Flight Center in Huntsville, Alabama. We've had a great time. We've got a lot of different information that we can talk about and share. One thing we heard earlier is we've got the concept of how does NASA handle space debris? How do we study space debris and who does that job? And so here at NASA's Marshall Space Flight Center, we deal with the meteoroids. And that's one reason why we have experts like Bill Cook and Danielle Mosier and Rhiannon Blau. They're meteoroid experts. And that's one thing we do here in our MEO office. But the Jet Propulsion Laboratory deals with near-Earth objects, NEO. That's asteroids and the Near-Earth Object Program. And then another one that we haven't talked about tonight is because it's not a meteor, but it's the Orbital Debris Program Office. Orbital Debris Program. Bill Cook mentioned that a couple times tonight. That's man-made space debris, and that's tracked at the Johnson Space Center in Houston, Texas. So 3 different centers, Johnson Space Center, Marshall Space Flight Center, and the Jet Propulsion Laboratory in Pasadena, California, that are all handling space debris and tracking it for the benefit of NASA, NASA spacecrafts, and NASA satellites. And so, once again, a lot of research across the agency that's done on protecting protecting spacecraft from meteors, meteoroids. And so, if we want to do a little bit of Perseid history, and I think this is interesting because we talk about the fact that the Perseid meteor shower comes from a comet, and comets on this really elongated orbit, and you only see them so often, if you even are alive when they come through on this elongated orbit. And so the Perseids were actually first recognized as an annual phenomenon that recurs every early mid-August in 1835. And so we're talking well before the Civil War, but it was in 1864, right toward the end of the Civil War, that the astronomers actually computed the Perseid orbits, and they noticed that they were similar to periodic comet Swift-Tuttle. And now the Swift-Tuttle comet was discovered 2 years prior in 1862. So within 2 years, it was the first time that they were actually able to positively associate a meteor shower with a comet. And so that was just right after the Civil War. High meteor rates in the 1860s. Same thing were due to the perihelion return of the comet Swift-Tuttle. And so, and now we're experiencing, this is every year, because every year Earth's orbit takes it through the debris trail left by the comet Swift-Tuttle, and that's what causes the Perseid meteor shower. The Perseid meteor impact, actually we talk about protecting spacecraft and satellite. In 2009, one of the NASA, United States Geology, I guess that's a USGS imaging satellite, a Landsat 5 in 2009, was actually impacted by a small meteoroid. It impacted the spacecraft, sent the spacecraft tumbling, but fortunately for us, we were able to stabilize and return the Landsat 5 spacecraft to normal operations within just a few days. So it goes to show just how important the shielding that we have on these spacecraft are, because not always is it going to, even though we try our best. In fact, in 1993, a European Space Agency communication satellite, it was called Olympus. It was actually impacted by a Perseid meteoroid in 1993, and that ended its mission. And so, of course, that's 20 plus years ago. So improvements on the bumper shields or the spacecraft protection systems that are on various spacecraft and satellites, something that we continually strive to improve year in and year out here at NASA Marshall. And so that's just one thing that we're working on of many things, actually. And so if we're talking about the calendar of events and moving forward throughout the year, we're in the Perseid Meteor Shower, which is active through through August 26th for 2015. Except the meteorites are going to start to die down. This is the peak. And from here, they'll start to get less and less and less. But it's not the last meteor shower of the year. There are several more coming up. The Orionids are going to be starting in October 4th and running to November 14th. And so that's a medium strength shower. It sometimes reaches high strength activity. And in normal years, the Orionids can produce 20 to 25 showers at maximum. And so we've got that to look forward to in just a few months. And that's just one of many. Another one that's before the end of the year is the Leonids. We heard Dr. Bill Cook talk about the Leonids, which are best known for producing really great meteor storms, especially several years they have these outbursts of meteor activity. In 1833, 66, once again just after the Civil War. 2001 was one of the most recent outbursts of meteor activity, and it's best seen when the parent object, now this parent object is Comet 55P or Temple-Tuttle. The Perseid is Comet Swift-Tuttle. In November, we can experience the Leonids meteor shower, and that's from Comet Temple-Tuttle. And it's not the fresh material we see from the comet, but rather debris from earliest returns. It also happens to be the most dense at the same time. And so unfortunately, it appears that the Earth will not encounter any dense clouds until the year 2099. So you can still see the Leonids meteor shower. However, we won't get that dense cloud, that outburst, for almost another 70 years. And so best of luck to all of us so that we're all around 70 years from now so that we can see that. We've got a lot of great videos that we've shown all night tonight. Earlier we heard Diego Sanchez, who gave us some, once again he was on our telephone interview, as well as some of our videos. And since we're talking to an international audience throughout the world, we asked Dr. Diego Sanchez if he would record a video in his native language for our Spanish-speaking audience. And we are fortunate enough that he obliged. And so here is Dr. Diego Sanchez giving a Spanish interview about his experiences and advice for following in STEM fields.
Mis responsabilidades científicas de mi trabajo es investigar el efecto que partículas pequeñas, granos de arena, tienen en la composición de las atmósferas planetarias. Estas partículas entran a la atmósfera, estas partículas que son de origen cometario o asteroidal o de asteroides, entran a la atmósfera con velocidades bastante altas y cuando encuentran las alturas más densas de la atmósfera, se calientan y evaporan su contenido metálico y forman capas metálicas en las atmósferas. Estos fenómenos sabemos que existen en la Tierra, en planetas como Marte o Venus, y en otros cuerpos como la Luna o Mercurio o asteroides. Estas partículas impactan la superficie sin ser detenidos porque no hay atmósfera que los desacelere y impactan a altas velocidades la superficie de estos cuerpos y liberan metales de la superficie que forman pequeñas capas muy delgadas de átomos metálicos alrededor de estos cuerpos. Bueno, yo tengo dos tipos de consejos para darles. La primera es que es un consejo que me dieron a mí cuando yo tenía 15 años, que era un estudiante de la escuela secundaria en Buenos Aires, y en esa época había salido el programa Cosmos en la televisión, y cuando lo vi me enamoré del espacio, y también lo que hice es escribir una carta a Carl Sagan, En esa época no había emails, así que escribíamos carta a mano. Y él me escribió después de varios meses y me aconsejó que para seguir carreras científicas uno tiene que estudiar mucha matemática y física. Básicamente era un conocimiento muy sólido de las ciencias básicas. Y eso es mi sugerencia académica a estudiantes que quieren ser investigadores. Saber mucha matemática, saber mucha física. Es muy importante tener esos conocimientos básicos. Pero también hay un consejo más personal que les daría, que es un poco abrazarse a los sueños, aferrarse a los sueños que uno tiene de chico. Para lugares como la NASA está poblado por gente que se aferró a esos sueños y sueños que a veces son un poco locos, como por ejemplo poner un hombre en la luna o un automóvil en la superficie de Marte, pero que si uno se aferra y trabaja mucho con equipos de profesionales con mucho conocimiento, los puede hacer realidad. Y eso es importante, siempre aferrarse a esos sueños.
Thank you, Dr. Diego Hunches. We appreciate all the effort you put into providing such a quality webcast and program for all our viewers all around the globe. Speaking in his native language for all our Spanish-speaking audiences joining us around the world. Just a tremendous opportunity to have him involved. My name is Christopher Blair. We've been joining you for the past 3.5 hours, providing 2015 live Perseid Meteor coverage from here at NASA's Marshall Space Flight Center in Huntsville, Alabama. Alabama is in the southeastern part of the United States. We are just above the great state of Florida and just not too far from the Gulf Coast, where the state is. However, NASA Marshall Space Flight Center is in the northern part of the state. We border the Tennessee, we're just right under the Tennessee border, kind of South Tennessee, and we've been providing a live feed for the past couple hours from our wide field camera. And that feed is giving you a look right here above the horizon at NASA Marshall, looking north, about a 63-degree angle. Looking north is one of the best directions if you want to see the Perseid meteors as they come through. We're reaching what's going to be near peak time for us here at our local time. For your viewing pleasure, the best time is going to be the few hours before dawn. So wherever you're at around the world, as long as it's nighttime and you get up a couple hours before dawn, you'll enjoy hopefully some nice meteor viewing with your own two eyes if you've got good weather. And so we want to wish you the best of luck on that. And if you can't get that great viewing opportunity, we appreciate having you along for our wild meteor ride here and enjoying our live feed, which is one reason why we had this webcast tonight, is to provide that for everybody around the world. And so we earlier had spoke about the way we protect our astronauts and our spacecraft and our satellites in space. And I mentioned a couple different missions that were impacted by meteoroids. It was a NASA USGS Landsat 5 spacecraft and a European Space Agency communications satellite called Olympus. One that actually, the Olympus mission from ESA was compromised by a meteoroid, and then the Landsat 5 was recovered. It sent the spacecraft tumbling, but we were able to recover it. And it just shows how important it is to protect our spacecraft because, once again, the spacecraft and satellites are providing such useful benefits to us. It's how you're getting this signal right now around the world. It's how you get GPS and communication systems. It's how it's remote sensing, which is the idea of using various, whether it's spectroscopy or LIDAR or sonar or radar. We're studying the salt salinity of the oceans with certain spacecraft. We're studying land erosion in certain parts of the globe, just to name a few of the benefits that we get. And so we know, so if we talk about some of the different other spacecraft that have been impacted, Mariner 4 actually was lucky in that it suffered no major damage, just another one of these spacecraft that did suffer. It was mid-September of 1964 when the Mariner 4 spacecraft was located midway between the orbits of Earth and Mars. So we're not talking about an orbiting spacecraft that's just above the Earth's atmosphere. We're talking about a space-traveling spacecraft that's going from point to point and leaving Earth's gravitational pull and going throughout our solar system. And as Mariner 4 left the orbit of Earth, and in between Earth and Mars, it encountered an unknown meteor system. Now, once again, this is 1967. So technology was definitely the best that they had at the time. At that time, we're preparing to land astronauts on the moon. As we, especially right here at NASA Marshall, as we're testing Apollo Saturn V rockets, but it's not the level, obviously, 50 years ago that we have now. So an unknown meteor system was able to impact the Mariner 4 spacecraft. The onboard meteor counter registered a 1,000-fold increase in flux for about 45 minutes, during which time the spacecraft was slightly torqued about its roll axis and had some of its thermal insulation ripped away. Now, we were showing you earlier some of the protection systems that we use on these spacecraft, because it's speed is of the essence when we're talking about damage to the spacecraft. If you're standing here in front of me and I took a paper wad, like a piece of paper, and I wadded up and I threw it at you, it's not going to hurt you. But if I could throw that same piece of paper at 20,000 miles an hour, it becomes a high velocity bullet. And that piece of paper or that fleck of paint does become very dangerous to spacecraft and satellites. And so protection systems are one thing, but so is the responsibility that NASA's Meteoroid Environment Office provides NASA. That's where Dr. Cook, Rhiannon Blau, and Danielle Mosier come into play, because they provide these forecasts for the agency so that we are able to determine what spacecraft we should or shouldn't launch, when we should do EVAs or extravehicular activities on board the International Space Station. Astronauts are well protected in the space station, not so much when they're outside in their spacesuit doing a spacewalk. And as we heard from Dr. Cook earlier, and this was new information to me, was the fact that we could actually take the Hubble spacecraft and rotate it using gyroscopes to protect the mirror from a potential meteoroid impact. And we do that with other spacecraft as well. And so that's just one of the many benefits that the Meteoroid Environment Office provides, that yearly forecast. In fact, I do know that there was a space shuttle mission in 1993 that was delayed due to the Perseid Meteor Shower. We didn't want to launch a spacecraft in the middle of an intense meteor shower, and that kind of forecast comes from the Meteoroid Environment Office. Hats off and kudos to Dr. Cook and his team for all that they provide. And so if we look around and talk about meteors and meteorites, we've had a great time explaining the differences. And so meteors, some facts about meteors. We've heard that they're bits of rock and ice that are ejected from comets as they orbit the sun. And then when the meteor reaches the ground, it's called a meteorite. And I hope that a lot of our viewing audience actually has found some meteorites. We heard earlier from Rhiannon that if you've got a rock you think it might be a meteorite, the best idea is to take it to a local university or a local science center or planetarium, someone where you can find some qualified employees with advanced degrees who can do an analysis of that. But you've got a couple telltale signs. If it's a magnetic rock, that's something that could possibly be a meteorite. If it's got a charred crust on it, if you can tell that it's basically experienced an ablative burning as it came through the atmosphere, that's another opportunity, as well as a really dense, heavy rock. Something small that feels just way too heavy for the size. Those are three telltale signs you might have found a meteorite, and you should take it to a local expert to find out for sure. And so it's interesting to understand that comets continuously eject this material every time they pass around the sun. And we noticed that when we were showing some images of the SOHO spacecraft. And these comets orbit the sun just like the Earth orbits the sun. They're on longer, elongated trajectories around the Earth. So some of them may roll around the Earth and the sun a lot quicker, such as Comet Swift-Tuttle, which has a 133-year sun helio orbit, versus, I think we said Comet Hale-Bopp and Comet Halley that have hundreds and thousands of years. And so we won't see some of those again for long times to come. And so, and we were also talking about, and I hope there are some happening tonight, is the meteor is the streak of light. So when you're seeing the light, That's just a meteor. It's not the actual rock. It's referring to the light. And sometimes those lights can be red and green and blue, different colors. The larger the meteor, the different name that we might get it. And so most of what you are going to see tonight is going to be a meteor. However, if it's really bright, and we have different ways to analyze and measure this, if it's brighter than the planet Venus, then what you may have seen is what's called a fireball. And so we're looking for those, are often referred to as a bolide. And if it's brighter than what would be a full moon, which would be an extremely bright object in the night sky, you wouldn't mistake that for anything else, then that would be a super bolide. And so hopefully you might have a chance to see some of these. These would be a little larger meteoroids, but we're still not talking boulder size at all. We're talking small pieces. And so it's a great opportunity for you to get out tonight and hopefully view and see some meteors. I know our team went outside earlier tonight and had a chance to go, and I saw one, and then we had to come back inside. And so I'm looking forward to going back outside and seeing. I'd like to see some fireballs. They're the larger meteors. The fireballs, though, they can range. If we're talking about the size of what they could be, the meteors that you're seeing are going to be small, but a fireball. I might have said this wrong, but a fireball is going to be anywhere from the size of a basketball could be the size of a small car. So we're talking about large pieces of space debris. And some of these meteoroids that survive the passage through Earth's atmosphere and hit the ground, if you find them, they're liable to be a little smaller, and that would be one of your meteorites. And so hopefully, best of luck to everyone that you get a chance to find a meteorite on the ground. And so it's been a great opportunity for a lot of people to go out there and see that. And so as we continue to talk about the Perseids and what you're seeing, one question I've seen on social media tonight is a little bit about the positioning. And so where this comes from, the Perseid constellation is named through Greek mythology. It's Perseus, which is a Greek mythological hero. And the Perseids seem to radiate from a point in the Perseus constellation. But as with all meteor shower radiant points, you don't need to know where the Perseus constellation is to watch the shower. Just kind of where the meteors appear, they'll appear in all parts of the sky. And it's kind of, we always talk about where the radiant is, but if you think about if you're walking down a set of train tracks, the train tracks appear to you to come together and converge in a distance, of which we know that's not the case. They're parallel and they don't connect. However, most of them you're going to see appear in all parts of the sky. And it's going to happen more and more gradually as the constellation starts to appear low on the northeastern horizon, which is one reason why our wide field camera is pointed north across the state of Tennessee, looking at the northeast horizon, because that's where the constellation Perseus is going to rise. And then gradually throughout the night, it gets higher and higher. So that's why we have been saying all night tonight that your best viewing is going to be right before dawn, the few hours before dawn, because that's when the constellation will be the highest. Perseids burn up. Most of them we heard from Rhiannon burn up high above the atmosphere. Why we see the meteors, but fortunately, maybe if you're lucky, you'll be able to get a chance to actually see some that would be on the ground. And so as we prepare to wrap up our broadcast tonight, we want to do a quick opportunity to thank some of the people that have joined us all night tonight. We've had a crack staff joining us, not only our guests here in the studio, but also everyone who's working behind the scenes, all our magicians behind the microphones and behind the cameras, James Bilberry, Mick Spears, Jonathan Clifton, all who work here at the television studio at NASA's Marshall Space Flight Center. We want to thank Janet Anderson, Public Affairs Officer, as well as Janet Sudnick, and Brian, our media specialist. Of course, our guest from the Meteoroid Environment Office, which was Dr. Bill Cook, Rhiannon Blau, and Daniel Mosier, who's been so grateful, not only tonight, answering as many questions as they could, but also for the past week or two, preparing for this event and throughout the year, because they come out and help us for various events. We have other programming that we provide all year long that they come out and support. And then, of course, our guests who joined us on telephone. Mark Freese, Kelly Pando, and Suzanne Foxworth from the Johnson Space Center in Houston, Texas. Dr. Diego Hanchez from NASA's Goddard Space Flight Center, part of the NASA Space Weather Laboratory. Dr. Petrus Jeniskins from the Carl Sagan SETI Institute at NASA Ames Research Center, as well as Mike Handke of the American Meteor Society, a great and all-star cast of people who were kind enough to take the time out of their night to join us and share some of their experience and their expertise all about not only Perseids and meteors, but also just space-based astronomy and their enthusiasm for that. And so that's been a wonderful opportunity to have them involved. I hope you've learned a lot. We've gone through and discussed the differences between. I think everybody now has a good understanding of that, as well as the differences between the meteors that you're seeing tonight and potential fireballs that you could see if we're lucky enough. And once again, remember, the fireballs are going to be really, really bright. That's going to be an obvious difference if you see one. We've learned where meteoroids come from. In general, most of our meteoroids are coming from comets, thus Comet Swift-Tuttle, which is responsible for this meteor that we're experiencing tonight, as well as the meteor showers that we're going to experience for the rest of the year. And so it's been a wonderful opportunity. I want to take the time to thank each of you for joining us for tonight's broadcast. It's been a pleasure talking Perseids with all our special guests, as well as all of you throughout the night and on our social media platforms. Once again, interactivity, interaction, and engagement with you is high priority for what we do at the agency of NASA throughout all our space centers from East Coast to West Coast. So we have 10 space centers, a NASA headquarters facility in Washington, D.C., as well as partnering facilities throughout the United States. And so we are all excited to have you involved with that. We've had a great time engaging all of you. We appreciate your involvement and your interaction. I want to encourage you to not only continue to follow us and talk NASA Perseids tonight, but to come back here tomorrow. Come right back here to NASA Television as well as NASA Ustream tomorrow, Thursday, August 13th, for two very special events that are taking place at NASA Stennis Space Center near Bay St. Louis in Mississippi, down on the Gulf Coast. So tomorrow what is happening is we're ready to take another step for our journey to Mars as an agency, and that's going to occur with an RS-25 engine test that we're highlighting with a couple unique events. So tomorrow, Thursday, August 13th, NASA Marshall Television Studio crew, half of them are here right now, the other half are in Bay St. Louis at Stennis Space Center, and they're going to help support a 10 a.m. Eastern Time NASA Social. NASA Social event is where we invite NASA Social users from around the country to come to a NASA event at their own cost, on their own dime, and participate because we, obviously, as an agency, we have the media, the press, professional journalism outlets who will come and cover our events, which is great. But as you've seen tonight, social media is king in a lot of different avenues. We reach a broad audience, and it allows for engagement. And so NASA Social is something that the NASA Social team for headquarters for NASA has really expanded on, and is a healthy heartbeat of what we do at the agency. And so tomorrow at 10 a.m., join our NASA Social, which you can view right here on NASA Television and on NASA Ustream. They're going to be taking questions online, as well as having several special guests talking RS-25 engines. And what are the RS-25 engines for? They're for NASA's Space Launch System, which several centers around the agency are involved with, but we take a heavy role here at NASA Marshall, managing the NASA Space Launch System. So tomorrow at 10 a.m. you can watch the NASA Social. However, later the same day, you can tune in also on NASA Television and watch the actual live RS-25 engine testing at 4:30 Eastern Time tomorrow, when they fire up one of those RS-25 engines at one of the test stands at NASA Stennis Space Center. And so it's going to be a great opportunity. We've done a couple of them already. We're going to do another one tomorrow, along with the NASA Social. And so it's been a great week. We've had a Reddit AMA. We've had tonight's live broadcast. We have tomorrow's NASA Social. We have tomorrow's live feed from RS-25. And so it's a great time to be part of NASA. It's a great time to be part of the NASA Marshall team. And until we get to see you again, I just want to take the time on behalf of everybody here at NASA Marshall, NASA as an agency, to thank you for joining our broadcast tonight. We appreciate your involvement. We look forward to talking to you on social media and in person in the near future. Thanks so much for joining our broadcast tonight, ladies and gentlemen. We appreciate it. Have a great evening.